Okay, we're back at it as we look at the basics, the essentials of geometry. Today we'll be looking at how we measure angles. And yes, we'll be talking about degrees and using that protractor. So don't get uh, messed up when you're talking about degrees, comparing degrees to temperature. There's a little difference there when we're talking about angles. So here we go. We'll get started right away. Let's just first off start out how we label and write angles. Angles are made up of two rays. Okay, the vertex is the common endpoint of those two rays. So I've got ray FE and ray FD. Okay, they're not opposite rays because they're not going opposite directions, but they share that common endpoint. We call that endpoint the vertex. Okay, so when we name them, we name the 3 points that make up those rays. So we go in order as we if we were to draw the angle. So angle EFD, put the little angle symbol in front of it, or angle DFE. We can go either direction. Or if it's the only angle there, we can name it by its vertex, angle F. Okay. Or sometimes there'll be a number down there in the angle by the vertex, and we can call it angle 1. So that's different ways that we name the angle. Okay. If there are multiple angles, so we've got angle CFE here and angle EFD, we call those adjacent angles. They're right next to each other. They share a ray. We also have angle CFD if we want to look at the bigger angle. So there's different ways that we could name those angles. So notice I mentioned CFE. I could say EFC for the same one. EFD or DFE to name this angle right here. Or CFD or DFC for the bigger angle. If I wanted to name this angle CFE, I'd refer to it as angle 1. If I want to refer to angle EFD, I could say angle 2. Okay, but now I can't just write angle F because that vertex works for all 3 of those angles. I wouldn't know which one we're referring to. So that's where you need to be a little bit more specific and choose one of these. Okay, as I mentioned before, we use our protractor to measure the angle. Angles are measured in units called degrees. For instance, WXZ is 32 degrees. We can say, well, the measure of angle WXZ is 32 degrees. Or if we're using the symbols, we can say the little m, which stands for measure of angle WXZ equals 32 degrees. So if I can take my protractor and I can rotate it over, we can see that, yes, that looks like it's approximately 32 degrees. Depending on degree of error here, might not be able to get it perfectly in there, but it should match up and see that's pretty close to 32 degrees. Okay, so let's talk about the different angles that there are. We've got acute angles, we've got the obtuse angle, and we've got the right angle. Now, how do we classify those? Let's take a look. Okay, acute angles, not acute angles. Right angles, not right angles. Here are obtuse angles. These are not obtuse. And then these are straight angles. Okay, these are not straight angles. Just take a moment to brainstorm and come up with a definition for those 4 types of angles. Pause it if you need to. We'll come up with a definite definition. I don't know if I can say that, but I just did. So we'll come up with that definition we can write down in just a moment. All right, so if we want to write this down to make sure we have a definitive answer for what is an acute angle, what's a right angle, what's an obtuse angle, what's a straight angle, here's what we have. Hopefully you came up with those. All the acute angles are greater than 0 but less than 90. Okay, so if we looked at our chart here, all these were less than 90 but greater than 0. Okay, the right angles, you notice were all 90. Straight angles were all 180. Obtuse, we figured were greater than 90 but less than 180. Okay, so you can pause the video and write those down if you need to. Next, let's talk about the protractor postulate. We talked about the ruler postulate before. This just talks about how we use our protractor. Okay, we make sure to get the vertex lined up on the wherever your protractor has, whether it has a dot or a circle, usually has. So you line that on the vertex, line up one of the rays along either the right side, or if you want to come along the left side here, and then you just read the angle. I can see right now that this is an obtuse angle, so I want to make sure that I'm reading the 140, not the 40. Okay. Sometimes people memorize, well, if this ray opens to the right, I'm going to read the numbers on the bottom, but then they forget that and forget the rule. So just keep in mind, does this look like it's greater than 90? If so, read the number that's greater than 90. If it looks like it's acute, we'd measure the other one. Okay. So, and then also, if we were to measure that differently, if let's say this ray was shooting up at 10 degrees, was our first one. If it were 10 all the way to 140, that would be 130 degrees. That's why it's easier just to line it up with 0. It's like with a ruler, you want to match it up with 0 to make it easier. Okay, so let's measure angles and classify them using this protractor here. So measure of angle KHJ. So if I'm measuring KHJ, start at K, go to H, and to J. So that angle starts at 0, goes up to 55 degrees. And if it's 55, means it's less than 90, which makes it an acute angle. Okay, GHK. Okay, so I'm starting here. Here's my 0. I'm working my way all the way over to where K is at 125 degrees. Okay, that would make it obtuse since it is greater than 90. Okay, next let's take a look at angle GHJ. GHJ. That one lines up on both lines. So it starts at 0 here, goes to 180. Or starts at 0 here, goes to 180 over here. So remember, if we wanted to write that out properly, I'd say measure of angle GHJ equals, oops, didn't want to do that, equals 180 degrees. Sometimes technology just doesn't want to cooperate. 180 degrees is a straight angle. Okay. And finally, angle GHL. GHL. You can see that one starts at 0, goes up to 90. So we'd say measure of angle GHL equals 90 degrees. And 90 degrees makes it a right angle. Okay, so that's how you can measure with your protractor. We'll do that more as we go along throughout the year. So now we'll talk about what's known as the angle addition postulate, similar to the segment addition postulate that we looked at earlier when we were talking about segments. Basically, all it says is if I've got this angle RSP and this angle PST, I know those form the bigger angle RST. So if I knew this angle was 30, this one was 40, I would know that the bigger angle would add up to equal 70. That's basically what that says there. If you'd like to copy that down, pause and go ahead. But just keep in mind, the understanding of what's going on. Two smaller angles here make up the bigger angle. So we can apply that in a situation like this. Measure of angle LKN is 145. I'm just going to label my figure there. So that angle is 145. Okay, I lost my pen. Try that again. So 145. And I'm given in the diagram that this angle LKM is 2x plus 10. This angle MKN is 4x minus 3. I need to find both of those angle measurements. So how do I do that? Well, I know these two smaller angles add up to the bigger angle. So let's form ourselves an algebraic equation. Why don't you go ahead and try to set that up and solve it, and check back in when you're ready to go. Okay, so notice I set up my equation, adding the two smaller angles, 2x plus 10, plus the measure of the other one, 4x minus 3, to equal the measure of the bigger angle, 145. Combine like terms, 2x and 4x to give me 6x, 10 and negative 3 to give me 7. That still equals 145. I subtracted 7 from both sides, then divided by 6 to get x equals 23. That's not quite what the question's asking us to find, it wants us to find the measure of LKM. So we would say, well, measure of angle LKM is equal to, and we would say, well, let's apply that. So LKM is this one here, 2x plus 10. So 2 times 23 is 46, plus 10 is 56 degrees. Okay, and then also we'd say measure of angle MKN is equal to 4x minus 3. So 4 times 23, which is 92, minus 3 is 89 degrees. And 89 plus 56 should equal 145, which, check your calculators or add it in your head, it does. So we're good. So that's how we can find any angle measure, set up an algebraic expression to find that. Okay. Now, let's just talk about, as we did with segments, congruence, and when we use congruence and equal. Two angles are congruent if they have the same measure. So if we're talking about their shape, their angle, we say they're congruent, use the congruent symbol. If we're talking about their measures of the angles, we say they're equal, because the angles are the numbers we're referring to. So measure of angle A equals measure of angle B. But the angle itself is congruent. Okay? So if we take a look at this figure here, what are the congruent angles? For segments, we use tick marks here. We've got the arcs here. So angle T and angle S would be congruent, and angle P and angle R would be congruent to each other. Okay? So if PQR is 130 degrees, and QRS is 84 degrees, and TSR is 121, hopefully you can find the other angle measures of those. Well, if S is 121, T is 121. And if R is 84, P is the same, so that would be 84. So that's how you can read diagrams when we're talking about when you see the arcs on there. Angle bisector, just like a segment bisector split a segment in half, angle bisectors, hopefully you can figure out what those do. Segment AD is the angle bisector. Segment EF is the angle bisector. You can see that this segment is not an angle bisector, neither is this one. So if we define an angle bisector, it's a segment that would split an angle in half, or it creates two congruent angles. Okay? So we'll apply that as we take a look at a problem here that uses an angle bisector. So the diagram on the right, ray YW bisects angle XYZ. Notice in the figure we indicate that with these two arcs that show the two angles are now equal to each other. The bigger angle is split in half. So if XYW, the measure of that angle, is 18 degrees, we know that if this is 18, this one has to be 18. Asks us to find XYZ. XYZ is this bigger angle, so it's 18. Using the angle addition postulate, 18 plus 18 gives us the bigger angle. So measure of angle XYZ would have to be 36 degrees. Okay, so that's all we'll talk about with angles today. So we've learned how to read an angle measure, how to label it. We've talked about how to use our protractor to measure the angle. We've figured out the difference between acute, obtuse, right, and straight angles. We've also discussed what makes an angle congruent, how we refer to the angles. We also talked about how to find an angle measure if we have two angles that add up to a bigger angle. And we also talked about the angle bisectors. So we'll do some practice with that in the homework. You'll also, when we get to class, we'll do some work with constructions as well. So any questions, bring them to class. We'll see you later.